So third question. Third question is similar to the second question. It is maximum likelihood estimator for binary distribution or Bernoulli distribution. It's simple because in this example, x is a binary distribution, so it's 0 or 1, 1 or 0, and probability of 1 is p, probability of 0 is 1 minus p. So simplest possible distribution in the world, in like a, right? Except for constants, this is the simplest possible example. And we, of course, the probability should be between 0 and 1, but we restrict the p to be strictly within 0 and 1. So if it's too close to 0 or too close to 1, some problem arises. So we assume that there is a minimum and maximum different from 0 and 1. And you can think it as the minimum possible number a computer can understand, for example. Because if p is 0, 0 and 1 is not allowed, so there should be some minimum number. So first question, show that expectation is probability. And so by the way, I had to write p0. I forgot the subscript 0 to denote it's the true value, but can be confusing. But please understand what is the truth, what is the generic value. Expectation is defined as an integration or summation. In this case, summation is enough. So simple, this is it. And this is by definition probability. So I have nothing much to say. It's this simple. And second, we'd like to write probability this way. This is the probability. And also it is simple. You can just check case by case when x equals to 0 and x equals to 1. So the idea is something to the exponent of 0 is 1, right? So if x is 0, this becomes 1, and this becomes 1 minus p. So simple. The other case, also straightforward. Nothing much to say. And when you take the log of this, it simplifies again, right? Simplifies. Log something multiplied by something can be split as log something plus log something, right? And log something to the exponent of something, and the exponent get out of the log and become a slope, right? So you get this. And then differentiate, right? Differentiation, log p differentiate, this derivative becomes 1 over p, right? Straightforward calculus. And first order condition, first order condition derivative, and the first order condition, by the way, I distinguish the true value and an arbitrary value. True value, arbitrary value. This so this should be 0, and its solution is simply p equals to p0. I believe you know how to solve this out. And then the second order condition is another derivative, and you have to check if it's negative. It is scalar, so it's negative, right? So it has to be strictly concave, so we need to show that it is strictly negative, which is not a big problem again. When p equals to p0, it equals to this. And by the way, for any p, it's negative, always negative, and it's always negative. So not a problem. Negative. Hessian matrix, simple. Variance, also simple. By the way, the variance of a binary distribution is this, right? P times 1 minus p is the variance. So, first order condition, also nothing special. just replace expectation with finite sample mean. Then as a solution to this, p hat equals to the sample average. And now time for bounds. We use bound C. Then you get this and you get these. So by the way, remember that log of p is always negative as long as p is smaller than 1. Right? Log of 1 is 0, and any number smaller than 1 becomes negative. So it is smaller than 0. So when you take absolute value, the only meaningful bound is this guy. Anyhow, this guy will be between this and this, so it does not matter. What you need is log of c. And I will replace log of c's absolute value as c, and you can show the other way in the same way. The other thing will be the same thing, the other guy. Then the bound, nothing much to explain. And second order derivative, also bounded, easily bounded, and easily bounded. And what? And then this is the final asymptotic variance. So yeah, I just do the calculus and algebra and nothing to explain as long as you know how to differentiate, how to solve an equation, simple equation. Okay, this is it. This is homework 3. So I hope the examples help you better understand the theory and compare how the assumptions are satisfied in this example. Okay, thank you.